I'm going to start off this morning by talking about handling data in YUI 3. And I'm Tilo, and I'm the intern on the YUI team. So with that, let's get started, right? So I wanted to start off this morning by talking about data in general, right? It's kind of what drives the internet. And I was listening to Christian's talk yesterday, and he summed it up really nicely when he said that the internet is basically data and interfaces. And while the interface can change based on what type of web application we're making, that data that's behind it is fairly constant. So it's kind of important to know how to manage that information and use it and send it to the interface that you're working with. So we've also been part of this trend over the last 5 years where we've had more and more data to work with, right? Even if you think about your personal website, it's probably no longer a collection of HTML pages. It's probably now like a blog with maybe a Twitter stream on it. We have, APIs like Facebook and Twitter, which are giving us huge amounts of data to work with every single day. And we have things like YQL, which take all these different APIs and give us a nice little syntax that we can use to access all of them. So with access to all this information out there, there's a big opportunity, but there's also a challenge, right? How do you manage all this information? How do you bring it to your page in a way and manage it so that you can work with it in an organized manner in terms of code? And if you're able to do that, then there's certainly a lot of opportunities out there because users are used to consuming data now. It wasn't the same 5 years ago. So this talk is pretty much about that. And we're going to talk about YUI 3, obviously, and how YUI 3 helps you in this process. So we in YUI 3 believe that there are a rich set of utilities that you can use to help you manage data. And our goal was always to make it as easy to use as possible for you guys so that the user can have a nicer experience. So when it comes to data, I like to think about it in these 4 steps in what I call the data lifecycle. There's retrieval, which is getting that data from wherever it exists on a remote server to your page. There's parsing, which is then taking whatever objects you get back and only taking the fields that you want out of it. There's normalization, which is type conversion, right? It's taking strings and converting them into dates or objects or numbers or whatever they truly represent. And finally, there's display, which is then taking all this data and plugging it into a widget in YUI 3. So we're going to talk about that. In YUI 3, there are actually utilities that help with each step of this process. So for retrieval, there's data source. Now, there are various ways to retrieve data in YUI 3. There's also like the JSON-P module. There's y.io. There's the YQL query module that we heard about yesterday. We're going to talk about data source because for a few reasons. One, it's kind of generic in that it has I/O functionality in it. You can query YQL with it, and you can work with JSON-P. And it works really well with the other utilities that are mentioned here. So it's a nice generic module, which I don't think gets the attention that it deserves, frankly. For parsing, we're going to look at data schema. For normalization, we're going to look at data type. And for display, we're going to look at some data-consuming widgets that are in YUI 3. We're going to talk a bit about the new autocomplete that's out. We're going to talk a bit about DataTable in YUI 3 and charts, which is in the gallery right now. So here's a high-level view of how all of this works in the YUI 3 world, right? You have some remote server, and data source is going to go fetch that data for you. You can then plug in data source with the data schema plugin, and what that's going to do is it's going to parse out only what you want out of that data. Additionally, you can use data type in conjunction with data schema, and you're going to get data back then, which is parsed and normalized for you. And finally, all of this is going to get consumed by a user-facing widget. So this is the high-level view. But what we're going to do in this talk is we're going to dig deeper into each one of these utilities, and then we're going to put it all together and look at some live demos and some use cases of when this would be useful, when you should use each of these, and when you shouldn't, right? And I hope what you're going to get out of this talk is that it's pretty easy to do all this in YUI 3. So on that note, let's start by looking at retrieval, which is the first step. So data can exist anywhere, right? It can exist in memory in a JavaScript array. It can exist on your server. It can exist in some third-party site. And using data source, we're able to get this data onto our page no matter where it exists. Excuse me. So that's what data source is in a nutshell. It lets you retrieve data from various sources. Some of the benefits of using this, you can cache requests if you want. And you can actually do local caching or caching online. and you can pull for requests. So that's kind of useful. And we know YUI 3 is very modular. So if any of you are familiar with data source from YUI 2, it was a monolithic module which had everything built in. In YUI 3, we've kind of split that up into subclasses that are mentioned here. So if you want to get data from, let's say, a REST API, you probably want to use datasource.get. If you're getting data from your server, you might want to use I/O. You can also pass in a custom function, and data source is going to get populated with whatever that function returns. We kind of talked about caching and polling. We're going to look at schemas a little later when we talk about parsing. So you can basically take whichever submodule you want and work with just that, and your file size will be a lot smaller. So one of the questions that gets asked a lot is, we already kind of mentioned, there are lots of ways to retrieve data in YUI 3. Why should I use data source, and when should I use it? And you shouldn't use it all the time. So these are some of the use cases that I thought of, and I don't think this list is complete, but probably covers a good deal of use cases. If you want to share data across widgets, so if you want to get some data into a data source and then pass a subset of that into an autocomplete, pass another subset into a data table, then data source is really good for that. If you want to transform data, so we're going to look at some of data source's event system. And if you want to transform data, you can hook into these events and do your own custom logic to manipulate that data before it comes back to you, and then send it off somewhere. And finally, if your data is not available in YQL, we're going to look at two examples in this talk. We're going to look at an example using YQL and using Facebook's API directly. If your data isn't in a YQL table and you don't want to or you can't write a YQL table at that time, and you're interacting directly off an API, then something like YQL query isn't as useful to you, right? So when I mean YQL query, I mean the YQL query module. So in that point in time, data source becomes a viable alternative for you. So let's look at some code. Can everyone see this? OK. So this is a pretty straightforward piece of code which instantiates a data source and sends a request. Let's take a look through this. So the first thing is I'm including the data source module in my use statement, right? So that's going to get the data source roll-off for me. I'm then instantiating the data source, and I'm saying, go to this source. And the source I'm passing in here is the YQL URL from where I can perform all my YQL queries. So that's getting sent in as the source. So now the data source is pointing to that source. And then I just use this send request method. And I put it in an object bag. And the first field is request, which is a URI encoded string of the query that I want to perform. Next, I just put in a callback object, which has success and failure functions defined on it. And those will get called as appropriate based on whether this request is successful. So that's pretty straightforward. And that's how you can basically get some data off. In this case, we're using YQL. We could be using the YQL query module. In this case, we're using data source. So data source has, just like in every YUI 3 module, it has some events that you can hook into to perform your own custom logic, right? We have request, which is fired whenever that initial request is sent using the send request method. We have data that's fired when raw data is received. We have response that's fired right when that data is sent to the callback object. And if anything goes wrong, it's going to fire error. Right? So hooking into these events is really straightforward, too. So here's some code that does that. So what I'm doing here is that when that initial request is sent, I'm just taking a button I have on the page and setting it to disabled and changing its value, and then undoing that after I get the response back. What's interesting here, what would happen if I had prevent default on request? So if I had prevent default on the request would never get sent, right? But if I have prevent default on the after response, it still goes into my callback object. It still goes into the success function, and then it takes this code. So that's how prevent default works with respect to these events. So on that note, I have a little demo. And I don't think anyone is going to be particularly impressed by the demo. In fact, part of the reason I have this demo is to show you of the shortcomings we have with this method. So you can see this. Okay. So what I have here is simple page. I have an autocomplete box. I'm using YUI 3 autocomplete here. We're going to talk about this a little later. This is actually taking a data source and querying YQL for some movie names. So, and then once I select a movie name, oops, gets me some information about it, right? Pretty straightforward. What I want to highlight here in the code is how exactly we're using one data source instance to send two different queries. So, okay. Here, all I'm doing is I'm including some autocomplete stuff, and I'm including data source, right, in my use statement. I have some nodes here that I'm working with, so I'm assigning some variables there. And then I have some templates because I do some string substitution for the display. Okay, here's kind of one important part. I have this URL object, and it has three fields, YQL, movie, and review. YQL refers to this, is that? Oops, sorry. Let me just zoom out a little bit. Everyone can still see that, right? Yeah. So YQL is this URL from where I can perform any YQL query, such as movie and review. Movie and review are just URI encoded strings of the queries that I'm going to perform. And I copy this directly off YQL. So I then have this dynamic movie request function. What this does is that when I press get reviews, it takes what's in this autocomplete box and generates a dynamic request based on whatever content is in there. So here's where I'm instantiating the data source, and I'm saying point to this URL here from where I can perform all my YQL queries. I have some autocomplete stuff that's going on here. We're going to talk a little bit about this later when we talk about widgets. But essentially, you can see I'm passing in a data source as a source. And whenever I'm typing stuff in, it's querying this query. I'm then taking my data source and plugging in the data source cache plugin, so it can cache the last 10 queries. And that's as straightforward as it gets. And then on request, I'm just doing what I was doing there. I'm changing the button to disabled and changing its value. What's interesting here is this, right? So I have one instance of data source. And when I'm typing in this autocomplete box, each time I type, it's sending a query off. And then when I press get reviews, it's sending a different query. So I have one instance, but I'm sending two different queries with it. So here what I'm doing is when the query I'm sending is, or when the request I'm sending is actually the request to get more movie information and not just names, that's when I want to do all this stuff. And the response is just the opposite, basically. And then the most important part is right here, where when I'm clicking the review button, I just send a request off to this dynamic movie request function that I had. And I pass in on success to display some movie details, which is just doing some DOM manipulation inside it, right? Some of the shortcomings that are here. One, look at the length of this object that I get back. It's huge, right? It doesn't even fit on here. So I don't really like working with stuff like this. So that's one shortcoming. Second, if you look closely here, YQL is going to return data to you, right? But the data isn't parsed in any way. So for example, I have a lot of nulls here, and I have zeros. And sometimes I might even get nulls in this entire overview section here. So I have no way to deal with edge cases. I'm literally just getting data, and I'm plopping it onto the page. We're going to look at how we can fix that and make data source handle all your edge cases for you, so your code after that becomes a lot terser. But I just wanted to show you this is an example of how we're actually using data source to fetch stuff and return it onto the page. All right, back we go. So with that note, I'm going to move on, and we've kind of covered retrieval using data source, and we're going to talk about parsing. So parsing is all about taking objects that you get back and only getting the things that you want out of it, right? When you're using YQL, this might not be too much of an issue because you can always say select this field, this field, this field from here. But if you're using Facebook's API directly and you're interested in newsfeed, you're going to get a lot of data back, right? And it kind of helps sometimes when you just parse out the stuff that you want. So in this case, we can use data schema, the data schema utility, to parse out only those fields in yellow and get an object that looks like that. So basically what you're doing here is you're parsing and filtering data using JavaScript. So why should you even use data schema? You can always kind of work with the entire object that you get back. And the reason really comes down to kind of it's easier to work with when your code breaks. So for example, if I'm working off of Facebook's newsfeed and I'm getting all this data back, and tomorrow Facebook changes their API slightly where now suddenly a field is nested within an object and it wasn't before, my code is going to break on my side, right? And it's going to be a little hard to diagnose what exactly happened. But if you have a schema in place and then you're working with that resultant collection instead of the collection that Facebook's sending you directly, you're working with objects with known properties now. So if something fails, you're going to get a null in that object. And you're going to see, OK, this null is coming from my schema, which is supposed to fetch this object. So obviously, it's not fetching that. So you can kind of track it back easier. So that's one of the reasons why you want to work with this. Another really good reason is that it converts XML and delimited text to JSON for you. So no matter what your server returns, you can work with JSON on your front end. So that's a bit of a looser coupling between your front end and your back end. That's kind of valuable, right? And data schema can be used as a standalone module by itself. Or I think the most popular use case is that it can be plugged in to a data source instance. So no matter which one you choose to do, really, you can specify schemas on some different data structures. XML, JSON, arrays, and delimited text. So let's see how this works, right? Let's see this in action with some Flickr data that I got back. So this is kind of small. You guys probably can't see it. That's kind of the point. Here's a collection of photo objects that I get back from Flickr. And there's quite a few fields on each photo object. I'm not necessarily interested in all of them. So what I can do is I can specify a schema on that data, and my resultant object is, or my resultant array of objects is going to look like this. So what exactly is that schema doing? Let's take a look through that. A good way to think about a schema is that it handles both tabular data, kind of keys to values, and then also metadata over that entire collection. And each schema has some different definitions that you have to pass into it. So here we're working with the JSON data schema, right? Because my data is in JSON. So we pass in the definitions of result list locator, result fields, and meta fields. What result list locator is it tells the schema, here's where the array is over which I want to iterate to find all my objects. So if you look at this initial data set, that array is in results.photo, right? So photo is an array with all the objects inside it. So that's what I pass into result list locator. Result fields is just an array of objects where you pass in the field, the key name for each field that you're interested in. So that's actually what you're going to get back from the schema. And optionally, you can pass in meta fields, which is kind of, this is stuff that I don't care about on a per object basis, but on a per collection basis. So in this case, that's how many objects were returned in total, and when was this query created. So that's passed in as meta fields. And then I just apply the schema on that set of data. And as I mentioned, schemas can be set on different data structures. And they vary slightly based on the type of definitions that you pass in, but in general, they're pretty straightforward to do. So here's the more popular use case. It's actually using data schema as a plugin to data source. So what we're doing here is right before we send this request off that we did before, we're taking a data source and we're plugging in the JSON schema to it, right? And then we're sending it an object with whatever we just talked about. So the object has a schema object inside it, which has the fields that we just mentioned. And that's pretty much it. So again, when to use data schema, I just want to reiterate this. If you don't have control over what your incoming data is, so you're working off of Facebook's API, Facebook's sending you a ton of data to work with, you don't have too much control about how much data you're getting back. So schema allows you a way to kind of know what you're working with. If you want to turn data into JSON, I don't really like working with XML, but if your server is returning XML to you, you can use a schema on an XML document and convert that into JSON for yourself. And finally, doing this ensures that your front-end code is kind of less coupled with your back-end server. So on that note, we've kind of talked about retrieval using data source and parsing using data schema. Let's talk about normalization. So when you get JSON back, everything comes back as strings. And this is fine if you want to just display that information. But if you're doing any sort of comparative operations or sorting or arithmetic calculations, then you don't want to treat dates as strings and numbers as strings. So normalization is all about converting this stuff into what it actually truly represents. And we're going to use data type to do this. So that's basically what data type is. It provides type conversion and formatting methods for dates, numbers, and XML documents. And it lets you work with the data in its proper format, which is really useful if you're doing any sort of calculations on that data. And again, it can be used as a standalone module, or it can actually be used in conjunction with data schema. And remember that data schema can be used as a plugin for data source. It's kind of a three-way system there. And just like data source was broken up into subclasses and submodules, data type is the same. You can we have some different subclasses, submodules that you can use based on what type of data you're working with, numbers, dates, or XMLs. It's really straightforward to use, right? Here all I'm doing is I'm sending in some submodules to my use statement to just work with. I just want to type convert here from strings to the object. So that's using the parse method on data type. So I'm just calling date.parse to parse out dates. And this argument can be whatever you can pass into a normal date object if you were creating that in JavaScript. And I'm doing the same with numbers and an XML document. Right? Formatting is kind of the opposite. It just stringifies objects into strings for you. And it's probably just as straightforward to do. Here I'm taking a date, and for dates it uses the string from time tokens, which you might be familiar from PHP. So the first one here does sort of a month, /date, /year, year. And the second one is a lot more kind of verbose in what it prints out. You can also do that with numbers. So here we have datatype.number.format, and we're passing in an object with some different fields on it. You can use this to customize numbers pretty heavily. And XML, right? Very straightforward. So one interesting thing that data type does is that it formats dates in different languages for you. And if your language isn't supported, you can register data yourself. So this is really useful for localization stuff. For example, this code here actually formats a date in Punjabi. What we're doing here is we're setting some tokens, and we're setting them to specific Punjabi arrays that we're interested in. So little a that corresponds to weeks in like short form, and big A corresponds to weeks in long form. And once we set those, we can set the language and format the date using these tokens, and it's going to output a date in Punjabi. That's kind of cool. So how do we use this in conjunction with all the stuff that we've been talking about, right? Data source, data schema. And it's straightforward in the sense that we're just using the parser object. This, for those of you who kind of worked with YUI2 data source, this is pretty much the same. So here's our schema that we had defined earlier. All I'm adding is the parser field and sending in a string, which can be a number, a date, or an XML. Or I could send in a custom function, as I've done here. And what this will do is we'll take, let's say, the ID field and make sure that it's a number. And it'll take the whatever is in server and make sure it's a number. And then I can apply that schema, and I have normalized data that's coming back to me. So remember that example we had earlier with the movie stuff. We're going to look at a slightly refined version of that now. So, let's see. I really like Star Wars, so. So now, this is really big on my computer. Now I have some sort of edge case protection. So if my certification isn't found, I have a not certified here. And I'm actually being able to deal with images, which I wasn't before. It's not that I put in the images here to make it look nicer. I wasn't able to really work with the images before I had the schema. I'm going to explain how that's working. And kind of the cool thing here is, since I have my schema in place, I can get a data table out on this page in a YUI overlay and actually kind of parse it, sort it as intended, because this data is normalized. So I'm not using strings here. I'm actually using dates and numbers and well, name is a string. So that's kind of cool. And sneak peek at YUI chart. So I can actually get a YUI chart to show up on the page. And this is just measuring number of votes that each movie got. And again, this is working because my data is normalized. So how is all this working? Let's take a look. So a lot of the code is actually the same. I'm including DataTable because I'm working with that. I'm including charts from the gallery, and I'm including overlay. The rest is the same as it was before. Again, same variables, same template. The template here changes a bit just because I have images now. The same URL object here, and the movie request function is the same. I'm still instantiating my data source in the same way, and autocomplete does not change. Okay, so here's where it changes, right? When I'm clicking the review button now, I'm setting a schema. And I tell the schema, so remember how before I was working with that really large, I was kind of going through the object really, really deep to find my array. I'm now putting that into the schema, and I'm saying, okay, here's that really large part that I want you to go through, and that's where the array exists that I want you to iterate over. And here are all the fields that I'm interested in getting back. And you can see I'm normalizing some of these. So popularity, I'm getting back as a number. Votes, getting back as a number. Released, getting back as a date. And then some of these are a bit more interesting. Certification. If it doesn't exist, instead of returning null, just give me not certified, right? Here's images, which was a little bit painful to work with. So this really depends on how good your YQL data table is and how well it returns something. But in this case, images returned to me an object with an array inside it, and each index in the array had another object. And that object was the actual image. So it's kind of an object with an array with objects of images. But the thing is, sometimes that initial object was null. Sometimes the object had only one image, so it was an object-object relationship. So what I'm doing here is doing some edge case detection, right? I'm just saying if this movie has any images, and that images is an object, and it has at least 3 images, and the reason there's a 3 here is because, again, this is how the table works, that in that index of images, 0 corresponded to the largest image. 1 corresponded to a really big image as well. 2 was a smaller, and 3 was like the smallest one. So this is kind of corresponding to a poster, a cover, thumbnail, etc. So I only want the thumbnail. So I'm saying if there is a thumbnail that exists, set the actual image value here of this key to the actual image. So I'm putting all this kind of detection here in the schema so that when I'm actually working with this data, my data is normalized and easy to use so that I don't have to put this stuff into my code anywhere else. And if there isn't an image, then just pass in this dummy image that I have with this width. Right? After that, I just send in my request as I was before. And what happens is now, in my movie details function, display function, I can work with a lot terser object right here because my object is coming back normalized. And I can take all my objects, and it has these nice fields on it that I've defined myself, so I know exactly what they are. And I'm just substituting that into my template. We're going to go back to this example later when we talk about widgets, and I'm going to show you exactly how that data table and charts works with this data that we've got back. So we've kind of covered these 3 steps using data source, data schema, and data type. But so far, I've just been talking about YQL, right? What if we're not using YQL to access all this information? So I have this little example here that gets nearby check-ins using Facebook's Graph API, just to show you how it would be if you're working with a different API. Nothing really changes. So we're using data source and data type. We're instantiating a data source instance here, and we're passing in just the Graph API URL as our source. So from there, you can perform any query on Facebook, and it'll do the appropriate Graph API query. And then I'm just using data schema plugin here to pass in a schema which works with so data. I got that off Facebook's Graph API. I just looked at what data it was returning to me and figured that the array is is inside the data object, and then I pass in some keys that I'm interested in getting back. And what I get back here is, well, I send in the request, and the request here is the URI encoded string, and I'm basically searching for pizza places around me, where me is the latitude and longitude of Yahoo, and distance equals 10,000. I'm not sure what 10,000 that is. I couldn't figure it out, so I assume it's like meters or yards or something. Because if it's miles, then I'm looking at the East Coast, I guess. And then I pass in a data access token that Facebook requires, and then our callback objects. So we take we have a collection of objects that looks like that, and that's just really the condensed version. It's really big. And we turn it into something that looks like this, which is just what we need for our purposes, right? So that's kind of an example of how easy it is to work with off a different API. It's really just your source, and then you can pass in different queries using the same instance. And we kind of talked about this. So you can send various requests using one data source instance. You can plug in a data source with a specific schema and then send a request to work with that schema. Then you can plug in a different schema and send a different request. The important thing here is that once you plug in a schema, don't send a request to something that doesn't work with that schema, because then you're not going to get any data back. I can show this to you in the demo, but initially when I'm typing Star Wars into my autocomplete box, I don't have any schema on that. When I press retrieve, I assign a schema, and then I do all my, I get all the data back, and then I unassign the schema, I unplug it, so that when I'm back to the autocomplete, I can still work with it. I'll take a look at that. So, display, right? It's all about how you take the data and then actually plug it into a user-facing widget. You can send in normalized data into this widget, or you can send in a data source instance. The widgets we're going to talk about are YUI 3 autocomplete, and Ryan Grove is going to be giving a talk on autocomplete later today. I highly suggest you go to that, because I was working a little bit with this autocomplete, and it's really, really nice. It's really slick. I know he's added some lozenge functionality like it has in the Mac, so make sure you attend that. We're going to talk a little bit about charts, and Trip Bridges here is the one working on charts. So any questions, you can go to Trip. And DataTable. Any questions about DataTable, I can try to answer those for you. I'm sure there are other data-consuming widgets in the gallery as well. So autocomplete. How do you plug in a data source to autocomplete? So what autocomplete is going to do here is it's going to go to this data source I've sent into the source field, and it's going to, every time I click, request whatever's in the request template. This was exactly what I was doing in my code there. And it's really easy. 5 lines of code. The other parameters on autocomplete, I don't want to really go through them, because I'm sure Ryan will do a better job than I will, so attend that talk. And we've kind of already seen this in action, but that's it in action, right? It's really, really fast, and you can do some caching on it. Well, data source does some caching for you, so it looks really fast. So, DataTable. DataTable is out in the preview release, and we can actually, in this case, we're not sending in a data source instance to DataTable, but we're sending in that normalized data that we got back. So what we're doing here is we're setting up a column set, which is basically an array of the columns that I want the data table to show. The keys I'm sending in here, so ID, name, count, and created time, those correspond to the actual fields in my object. So the ID field in my object is going to come into that column. And then we instantiate our data table using datatable.base, pass in what we just created here as the column set, and as the record set, we pass in our normalized array of objects. And we plug in data table sort functionality on that and render it. And that's basically going to render what you saw here, a data table that allows you, that can be sorted. And if your data is normalized, it's going to sort in the correct fashion, right? And you can take this date and make it shorter if you want. I didn't, but. And finally, we have charts. So here's how that works. And Trip, correct me if I'm doing anything wrong here, but from my use of charts, we're passing in my data is our normalized array of objects. We're passing in my data to data provider. And in series keys, we're passing in an array of all the different series we want to plot. And that corresponds to the fields that are on our data. So similar to how column set was working, series key kind of works in the same fashion. And category key is the category that's along the x-axis that we want to plot this all against. So that for me, that's movie name. And we set some other style parameters on that, and we get something that looks like this. It's really straightforward, but you can kind of see how you can make this look a lot nicer. So some takeaways that hopefully you have got from this talk is this idea of this data lifecycle, right? Retrieving, displaying, retrieving, parsing, normalizing, and displaying, and working with the utilities that YUI 3 provides you to help with each step to manage that data better. So using these utilities in YUI 3 gives you a lot of benefits, and I've listed some of them here. We've kind of talked about all of these in some context. You have events that you can hook into for custom logic, looser coupling between the front end and the back end because you're working off JSON now. Different transport options. Data source allows you to use I/O, the get utility. You can do formatting and parsing. You get to work with objects that have known properties. You can do caching and polling for requests that you're sending out. You get predictable behavior because you know what fields the objects are supposed to contain. You get terser code. I handle all my edge cases in the schema. So then when I'm actually working with this normalized piece of data, my code is a lot simpler because I know exactly what each object has inside. And as a result, you get less edge cases, and you can take advantage of YUI 3's modular structure to only take the data that you want. And we're really just scratching the surface when it comes to working with data in YUI 3. As I mentioned, there are tons of modules out there. If you're working with YQL, I highly recommend you actually go through the YQL query module. There's also the JSON-P and the I/O module. So, and even in the utilities that we've covered, I haven't gone through the entire API docs because the APIs are there for that, and the documentation is really good. So if you have questions, you should definitely go to the API docs, examples, the forums on YUI library, or you could ask a question here. And control the data, don't let the data control you, which is kind of what happens a lot of the time when we have so much data to work with. And that's all I have for you today.